y'all didn't watch the video. Some of y'all didn't watch the video, and y'all are whining and complaining that you don't know how to do the problems. So I guess I'll have to go over them again. Go over what I went over in the video. So go ahead and write down this. That's p hat. We already talked about p hat. That is the point estimate. That's what you're going to be using to test the null hypothesis. P hat is equal to x over n. And the complement to p hat is what? Q hat. And I don't call it 1 minus p hat. I call it q hat. So make sure you know p hat and q hat. Q hat is equal to 1 minus p hat. So when you see that 1 minus p hat, that's what I call q. When did y'all come in?
Me?
I didn't see y'all.
I just.
Who? Me?
You and her.
I've been here for like 15
Well,
minutes.
I didn't see you because of the monitor, I guess. I'm sorry.
I heard your whole spiel about LSU
Oh, okay.
and politics.
Okay, so you were here the whole time.
Yeah.
I'm sorry. I just didn't see you because of the. I know I don't get to see most of this whole side because of that. Sorry. All right, so we got p hat and q hat, x over n, 1 minus p. Now, when you use this, when you're given x over n, when you're given x and n, if x is equal to 25 and n is equal to 100, then that's equal to 0.25. So if p hat is 0.25, what's q hat?
0.75.
Okay. All right, so that's p hat and q hat. Now, I will admit that if you look at the slides for 8.1 and 8.2, they could have put the good information on like 3 slides. They did a lot of, I don't know, BS. They put a lot of BS slides in 8.1 and 8.2. It's not necessary. This is your first thing you need to know in 8.1 and 8.2. Capiche? Next thing. The next thing you need to know, if I can get there, sampling distribution of p hat. Now I want you to read this because it says, for a simple random sample of size n with a population of p. Do y'all remember in 6.1 and 6.2, MPQ? The square root of MPQ? Y'all remember that? That's what this is. Okay? So you got to remember right here, what is that? That's not NP times 1 minus P. That's NP what?
Q.
NPQ has got to be greater than 10. Okay, so you got to check it. And then the mean of the sample distribution of P hat is what? P. And then the standard deviation, and I don't use this, it's going to be equal to the square root of P what? Q over N. Now remember, that section, I think it's the mean is equal to NP, and then the standard deviation is equal to NPQ. The square root, remember that from I think it was 6.2. Remember that? Well, that's where this is coming from. This derives from this.
What's the difference between p hat and p?
P is usually given. P hat is usually, well, when we get into chapter 10, you'll see the difference between the two. You test with p hat. P is usually given, and then when you test, you look and see where P hat is in relation to P, and then that's where you reject or fail to reject the null hypothesis. You got to compare them. So we'll get into it later with chapter 10. Okay? Right now, we just got to find P hat. That's what we got to work on right now. It'll all come together in chapter 10, I promise. Okay? All right. So you got two definitions with p hat, and then you got a definition here Okay, you got a test of NPQ is greater than 10, and then to find the standard deviation of the sampling distribution is that number. Now, right now, as she said, right now, separate, you don't know what all this does. Okay? But when we put it all together, you're going to say, oh, I remember, okay, I remember that. It's going to come together. All right? Next one. The mean and standard deviation of the sampling distribution. Okay? Suppose that a simple random sample of size n is drawn from a large population. Okay? This is when you have a mean given a mean and standard deviation. They give you a mean and a standard deviation, and then they say, well, what if blah, 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 what is the new standard deviation? And there it is. Okay? So that's going to be your old standard deviation. I'm going to put standard deviation given over the square root of n. And they will give you an n also. So they're going to give you an n, and they're going to give you the population mean and the population, and then they're going to say, you know, what if? And you're going to stick that in there. In fact, on the first slide that I picked out, we're going to do one of these. Okay? And out of 8.1 and 8.2, those are the three formulas or the three slides that are most important in 8.1 and 8.2. All right, so I'm going to show you. I'm going to go to the handy dandy slides. Let me get out of this. Give me a second. And pull up. There we go. So I want you to write this one down. It says, according to a time, you don't have to write down every single word, but write down 42% of registered voters believe that gay and lesbian couples should be allowed to marry. Suppose that we obtain a simple random sample of 50 voters and determine which voters believe that gay and lesbian couples should be allowed to marry. Describe the sample distribution of the sample proportion for registered voters who believe that gay and lesbian be blah, 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 blah. Okay. All I care about, there's only 2 or 3 numbers in this whole thing. There's 0.42 and there's 50. Okay, 0.42. We know that's a percentage, so that could be P, and that sample of 50, that could be N or something like that. So we look and we go to the next page and look at there. NPQ. How do I know to use NPQ? Because you're only given N and what? P. You got to do something. So NPQ. So this is a prime example. I'll go back. Hold on. I'll go back because I know some of y'all wasn't finished copying. So I'll give you a minute to copy that down. Because this is a test question. It's a homework question. So I don't think it's a standardized test question. Because I doubt very seriously that they would even, unless they give you the formulas, they're not going to test you on something like this. Okay?
What does NPQ find?
Hold on. There we go. NPQ and square. NPQ is the variance, and of course, what's the relationship between the variance and the standard deviation? Square root. And you also have to test it to see if it's above 10. You got that down? I believe it's a bad day. I'm catching vibes. Is it a bad day today?
Pretty good.
Okay, so far it's pretty good. Okay. Okay, so, and the reason I'm doing it like this is because I want you to get, this is how it's going to look. First, we got to test it. Now, if it doesn't test above 10, then what? You can quit and go to the next problem and say cannot be done. But I doubt very seriously that you're ever going to get one of those as far as the test. It's not going to work, okay? So, boom, there it is. And then you find the standard deviation. So this problem, they give you N and P. So if they give you N and P, then you know it's going to have something to do with NPQ. Question. And I promise you this will make a whole lot more sense when we get to chapter 10. Because if I showed you chapter 10 first, half of you would be lobotomized. Because it crams everything together. And I don't want to do that. Everybody got it? Compute probabilities of a sample proportion. According to the Centers of Disease Control and Prevention, 18.8% of school-aged children 6 to 11 are over blah, 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 blah. Okay? All you need is that 18.8%. Now, in a random sample of 90 school-aged children, what is the probability that at least, okay, we got a different problem here. Right now, all they're giving us is P, right? And down here, they're giving us 90, but they're saying, what if? And then down here, suppose a random sample of age, what results in 24 overweight children. So we've got a different problem. We got a what if problem here. Okay? So you test it. NPQ, that's equal to above 10, so it works. And then P hat is approximately normal, okay? P hat is normal with a mean is equal to 0.188. That's what they give us, 18.8%. So now we're going to get a standard what? Deviation. Now, look right here. What did they do right here? Well, that looks like X minus the mean over the what?
Standard deviation.
And what is X minus the mean over the standard deviation? Z-score. And once we got a Z-score, we can find what? The area. 4 digits. Now, let's go back to the original question. There. Now, random sample. What is the probability that at least 19% are overweight? What's at least mean? That means your lowest number is equal to what? So that means to the right or left of 19? To the right. So let me go back. So that means to the right there, sorry. 0.0485. Now, is that more or less than 5%? 5%. That's right at 5%. 0.05, and that's what they're saying right there. So, and they're taking away, I don't understand why they're doing the 1.5. I don't understand why they're doing the complement, but that's all I want is the Z-score right there. I meant the area, 0.0485. And B, suppose a random sample of 90 school children aged 6 to 11 results in 24 overweight children. Well, here they give us what? X. This is X. X over what? N. Now, the only way you're going to learn these are to practice them, okay? If you think you're going to be able to do them the first time you try them, they're not. Because one, they've broken them up. Two, you're not going to see how they're used until chapter 10. So it's kind of like trial and error with 8.1 and 8.2 and 9.1 and 9.2 because they've broken everything apart. And then they put it all together in chapter 10. So don't feel bad if you're a little bit confused. It will iron itself out by the time we get to chapter 10. Okay? So 24 over 90 is 0.2667. So now you put 0.2667 in, and that's 1.91. That's your z-score of 1.91. That has an area of 0.2667. So what they want you to do in 8.2 is they're wanting you to plug and chug into these formulas. Okay? And the only thing you need to do is be able to know which one. I think we just did that one, right? We just do that one. I'm trying to find where we were. Right there. Is that where we were? And that's it. Okay? So let me get back to 9, because I want to get back to 9. Where did we leave off with 9? I mean, what was the last thing we put in your notes on chapter 9? Margin of error? Well, that's probably going to be the end of 9.1. Point estimate. Upper bound. We did N, didn't we? Didn't we do N?
Yeah, we did.
I think we did a couple of questions with N. And that's PQ, and that's without PQ.
We did that one.
And I think we did this one. We should be going into 9.2. Yeah.
We are.
There we go. Point estimate. Here we go. Point estimate. You can do a point estimate with a proportion, or you can do a point estimate with a what? A mean. Now this is where a lot of people are going to say, wait a minute, I thought we did a point estimate. You're going to be given different type questions. All right? Some questions lead off with a proportion. Some lead off with what? A mean. So this is what happens when you do a point estimate with the mean. Now, what is a point estimate? A point estimate is a test point. You're going to use it in chapter 10 to either accept the null hypothesis, or fail to reject the null hypothesis. Okay? So you're either going to reject the null hypothesis or fail to reject the null hypothesis. Fail to reject the null hypothesis is the same thing as saying what? Accepting, but you can't use the word accepting because it's not 100%. Okay? It's a little play on words. All right? There's reject the null hypothesis and fail to reject the null hypothesis. So, for example, the sample mean, X bar, is a point estimate of the population mean. Okay? And you see that we go through and we got an example here, and you can go through and find the actual mean, and that's what they did right here, 2.464. Now everybody knows how to find the sample mean by your test scores. I'm not going to go over that because most of you know how to do it. Okay? Here is what happens when you've given the mean. Now instead of a z-score, you got to turn it into a what? A t-score. So go ahead and write that down. You're either going to turn it into a z-score with a population, or are you going to turn it into a t-score with a mean? Now, in chapter, I can't remember where it is, but there's another score. I mean, the z-score, I think it's called, I can't think of it right now, but anyway, there's another formula, and it looks just like this one. Instead, it's z is equal to x bar minus rx bar minus mu over, and then it goes s over our omega over the standard deviation of n. So is there much difference between these two? No. So it's not like you're doing something new. You're just plugging and chugging. Now, in the chart, and there is a T in your technology, in your TI-81, TI-84, whatever, you've got T distribution also. And we'll pull that up later. And that's going to be n minus 1 degrees. So if you are looking at the table, you're going to use n minus 1 degrees when you look up the T value. And we'll get to that. Okay? They might show it in the slide. I hope they do. There it is. Okay. They went ahead and showed it. So anyway, it says, comparing the standard normal, obtain 1,000 simple random samples with a size n is equal to 5 from a normal population with mu is equal to 50 and sigma is equal to 10. Okay? And it says compute z and compute t. So they're just giving, this is a plug and chug exercise. What they're trying to do is show you that the two formulas are really the same formulas, except one is for z and one is for t. It's kind of like the standard deviation for the population and the standard deviation for the sample is the same formula. Okay? Nothing different. All right? So you plug and chug. I'm not going to worry about the histogram. That's for Z, and that's for T. So is there much difference between Z and T? There's not much difference because you still see what? A normal what? You still see a normal curve. So it's not much difference. You see a bell-shaped curve, blah, blah, blah. And blah, blah, blah. This is just stuff. Bell-shaped center. We just said that. The T distribution is different for different degrees of freedom. The T distribution is centered, blah, blah, blah. The area under the curve is 1. Nothing, I think everybody can see that from the normal curve. The area in the tails is a little greater. There you go. That's the two. It's not a big deal. I don't know why they're showing us all this, because to me that's not. Okay, write this down. The notation T sub alpha is the T value such that the area under the standard curve is to the what? To the right. What is it with the Z value? If you look it up on the table, it's to the what? To the left. You got to remember that. Now, with your calculator, it ain't going to worry about it. And it's going to, some of these calculators drive for you, okay? They do everything for you. That's why we got people that can't make change and can't spell race car backwards. But, you know, I guess it's okay, but a lot of people depend on it too much. Some people are spelling race car backwards right now. Find the T value such that the area under the T distribution to the right of the T value is 0.2. So that's 0.2000. Assuming 10 degrees of freedom, that is T sub 20% with 10 degrees of freedom. So they're just rewriting the question. Well, first thing you're going to do is draw a picture. Now, the only difference here is, what do I usually do with area? Do I do 2 digits or 4 digits? I do 4. So I would change that to 0.2000 because that would mean that's an area. And then degrees of freedom is 10. If you was to look in the table, it would say 0.879. Or I'm saying you would say 10 degrees of freedom, and you would go down to 0.2000, and you would come out with 0.879. And I'm hoping they show you how to do it on a calculator, but I don't know if they're going to show you or not. But go ahead and draw it. Again, am I going to test you on this? No, probably not. Are you going to be tested in Chapter 10? Yes. Are we going to do problems with it in Chapter 10? Yes. So it's kind of like warming you up. I think if somebody look in your outline, don't we just cover 9.1 and 9.2?
Yeah, we do.
And then we jump into 10. And that's where we,
Take them through 10.1, 10.4. So.
Yeah, that's where we get most of the, that's probably as far as we're going to get. What's after 10.4?
Yeah, that's all it is. 10.1, 10.4.
Is that all Unit 4? Or do we go somewhere else? Somebody look in the outline. What does it say after 10? Does it say 10.1 through 10.4?
Yeah.
And then what?
Review and then the test.
Okay, so we only get 10.4. I don't think I've ever made it to 10.4. I usually get 10.2 or 10.3. Now, if y'all want to really go 10.4, we will, but I'll try to waste as much time as I can. All right. Okay, they're not going to show us, so I'm going to have to show you on the calculator, but we'll get to that when we get to it. All right, the table, let me go ahead and see if I can pull up the T table right quick so you can see it. No coughing in class. You need to lay off the Marlboro Reds, girl. I'm trying to find it. Hold on. There we go. What's the name of this book? Sullivan? Is it Sullivan or Long? Sullivan, isn't it?
Yes, Sullivan.
Sullivan T table. Really? Let me do PDF. That'll get rid of all the tables. Damn Russians. I'm looking, okay, here's Sullivan. I don't know if it's the right edition, but that's 2013. Let me go up here and see if that's it. Okay, so what was our degrees of freedom? 10?
Yep.
And then with degrees of freedom, and there's the 0.879 right there at 0.2. Now, we're going to get into one tail and two tail in Chapter 10. In fact, I want to go ahead and show you that. And a lot has to do with equals. All right? We're going to get into that with 10.1, which is equals. So, how do you look that up? Well, 10 degrees of freedom. Let me blow it up so y'all can write it down. Okay, there. So I want you to draw a picture. Just draw a picture or say Google Sullivan T-Table PDF. Print it out so you'll have it just in case, and I'll show you how to do it on the calculator after I refresh my memory on the calculator, because I don't depend on the calculator like some people do. But anyway, and you have not been given two tails yet, so it's assumed what? One tail, and it says greater than, didn't it? I think it said greater than. Somebody help me out. I think it says greater than. So greater than would be a one-tail test. All right? So that's where you get the 0.2. You go down. 0.2 at 10 degrees freedom is 0.879. Okay? Y'all don't seem too happy. Y'all, I'm getting bad vibes from y'all. I don't know what it is. Y'all get drunk last night or what? Hammered? Okay, well maybe that's it then. All right, let me pull up. I want to show you a little bit of 10. And a lot of you are probably spazzing out right now. Oh my God, he's going into 10. Y'all need medicine, okay? Because this is where we're getting into the meat right here. And you can when you get finished with chapter 10, you know what you can do? Go back to 8 and 9 and make 100 on the homework.
You gotta open it back up.
Yeah, I probably will. Is that why y'all are in a bad mood?
Yeah.
I thought I opened it back up till tonight.
I did, but it's still
And I
hard.
still don't get 8.1.
Okay, I'll leave it open. How about that?
Yeah, just leave it open until the test.
Okay.
Thank you.
You're welcome. That's why I'm getting bad vibes. Y'all are calling me a bastard. That's why.
No, you're mad at me.
Huh? I'm sorry, what? What'd she say?
She said we were mad at you.
Yeah, I kind of felt it. I was like, damn. All right, so here we go. No, I'm not going to do that. Not going to do that. Not going to do that. I don't like these slides.
Caution. Caution.
Okay. What is the null hypothesis? The null hypothesis is what is stated in the question. Write that down. It will be stated in the question. H of O is a statement to be tested. The null hypothesis is a statement of no change, no effect, or no difference, and is assumed true until evidence indicates otherwise. So if the question says the number of M&Ms that are green are greater than 10, then that is the null hypothesis. If it says the number of green M&Ms in a bag of M&Ms is 10, then that's equals. Then that's the null hypothesis. Everybody with me? The alternative hypothesis is what contradicts the null hypothesis. So let's see. If I tell you that 10 M&Ms are green, then my null hypothesis is X is equal to 10. Then what's the opposite of equals? Not equals. Okay? And then we're going to get into it. So it's the question will be the statement, the null hypothesis will be in the question. Will be in the statement. Okay? And that's H of O. Always write down H of O. That's the null hypothesis. And your job is to test the null hypothesis and to see which one's right. Okay? So there is accept the null hypothesis, and then reject the null hypothesis, and then fail to reject the null hypothesis. Now, I cannot tell you to use the word accept because I am a teacher and I'm not supposed to tell you that. But when you think of fail to reject, that's what you should think about. All right? Fail to reject is kind of the same thing as saying what? Accept the null hypothesis. But I didn't tell you that. All right? Because when you accept the null hypothesis, you're saying that it's 100% true. Now, if I open up 500 bags of M&Ms, do you think each one of them is going to have exactly 10 greens in them? No. So that's why you can't say accept. Is it a play on words? Is it splitting hairs 3 ways? Yes. Really? Really? You've got M&Ms and y'all are counting. That's what I should do. I should bring y'all all a bag of M&Ms and we should test this theory, right? Y'all suck. Y'all a bunch of prostitutes. Give y'all M&Ms and y'all, hey, yeah, I do it, yeah. A bunch of chocolate prostitutes. I guarantee you somebody's going to go to my boss and say that I called y'all a bunch of whores. All right, alternative hypothesis is H of 1. Write that down. That's the alternative. The alternative hypothesis is what's going to either validify the null hypothesis or it's going to say it's wrong. Alternative hypothesis is a statement that we are trying to find evidence to support. No sneezing in class. And there you go. Now, you're going to see, okay, and it's very important. I'm just going to put them both. Oh, shoot, I didn't put them on the same page. Okay, so there's the first one. Write that one down. These are the only three ways that you can set up these problems. And this is a two-tailed test. Why is it a two-tailed test? Because it's equal to and not equal to. And of course, less than or greater than would be a one-tailed test. Two-tailed means this, people. Now, why is that important? Because in the future, you're going to take your test point or your point estimate and see where it falls. Is it going to fall in the normal area, or does it fall in the what? The shaded area. If it falls in the shaded area, then you fail to reject. If it falls in the normal area, you accept or reject. I can't remember which one it is right now, but anyway, we'll get to it in a minute. All right? So that's the two-tailed test. Where's the tails? Here's the one tail, and here's the other tail. I don't know why they don't do this on the, I don't know why they don't put it down here. They got plenty of room, but I don't know. Okay, what's the next type? You've not finished? Okay, remember, you don't have to write these words for, you don't have to write in this chapter there or two, you don't have to write that. Just say equal sign, VS, not equal sign. Two-tailed test. Now, what's going to determine what you use? The question. Do you remember me telling you in Unit 1 that you're not going to fail this class because of the math? What are you going to fail this class because of? Reading. Okay? In Chapter 10, this is where the reading takes effect. If you don't read the question at least 2 or 3 times, if you don't pick it up the first time, read it 2 or 3 more times. Okay? If your reading comprehension sucks, then you might need to get a partner. Okay? The reading comprehension don't suck. All right, here's the next one. Left tail. Why is it left tail? Because you're pointing to the left side. Less than. What's going to tell you that? The question.
So H of all be equal. Not always, but.
Pretty much. You'll see in the examples. Now here, please don't write that first sentence again. Just write equal sign, VS, less than. Left tail. So, of course, it's going to look like a left tail test.
So what do you call HA? What do they do?
HA sometimes is written as H1. Some books put it H of A, some people put it H of 1. And then if one is a two-tailed test and one is a left-tailed test, then by deduction, what do you think the third one is? Y'all are gifted and talented. Y'all feel good about yourself? Good, then you don't need to wear too much makeup or wear sunglasses in the building. Now, is it very important that you understand these three methods? Yes. I guess besides learning, number one, besides learning 8.1, 8.2, 8.3, 9.1, and 9.2, the second part would learn these three types. Okay? Learn these three types. And of course, this looks like a right tail test. That's a right tail test. Now, do you remember in the t-test, it had up there, it had one tail, and then it had what? Two tails. That's what we mean. So you've got equals is two tail, and less than or greater than is what? One tail. Question. The null hypothesis is a statement of status quo. Status quo, for some of y'all that are not talking while I'm talking, means what? Equals. It means what? What is going on right now? Or no difference. And always contains a statement of equality. Boom, there it is. The null hypothesis is assumed to be true until we have evidence. When you test your points on the graph, on the curve, when you test your points. Do you remember us doing LBJ versus Shack? That's technically what you're going to be doing now. You're going to be taking a p-test and a p-hat, p versus p-hat, or a mean versus a mean, and you're going to plot it on there, and if it fits in the normal region, it's this, and if it fits in the outlier region or unusual region, where based on those z-scores or t-scores, then that means you fail to reject or you reject, whichever the case may be. But we're going to get into that.
So all H1, H8 is trying to make it where it's not true.
Say again?
H1, H8 is trying to say that it's not true.
Yeah, you're testing the null hypothesis. And either you're going to reject the null hypothesis, which means you're going to favor the alternative, or you're going to fail to reject, which means you accept. Okay? You need to sit in a dark room and think about that for a minute, okay? I'm serious. Because if you try to make sense of reject and fail to reject, you're going to get confused. You need to say, okay, reject means reject and accept. Fail to reject means accept. Okay? So you need to get that in your head. And the only way for you to get that in your head is to sit down and actually think about it. Because I'm going to tell you, we are in, right now, the hardest section in probability and statistics. Okay? For each of the following claims, determine the null and alternative hypothesis. Okay, this is three good examples. In 2008, 62% of American adults readily volunteered their time for a charity work. A researcher believes that percentage is different today. 62%, that means what equals. Okay, so your null hypothesis is 62%. All right? What is the alternative hypothesis? Different means what? Not equal. Different, write that down. Different equals not equal. Or different is, and then put a not equal sign. All right, what does B say? B say, according to a student, blah, 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 blah. The mean, I like the word mean, of a phone call is 3.25. So in this case, it's not P, it's what? Mean. So equals 3.25. So you would do mu, or if you want to use X bar, it doesn't matter to me. But if they're talking about population, you would use mu. So in this case, and I'll just write them both of them. This one this one right here would be P is equal to 0.62, and H of O is equal to 0.62, and H of 1 or H of A, whatever you want to call it, is not equal to what? So what kind of tail test is this? Two-tailed test. And that's what you need to be doing on these questions. What does it mean, and what kind of test is it? That's the two things you should be doing on these questions. So I draw this, and then I go out here, and then I do this, and then Now what do we do after that? We go back and do some of the stuff in 8.1 and 9.1. Yes. Okay? According to a study, blah, blah, blah. So the mean, H of 0, is equal to 3.25. H of A, or H of 1, I don't care, is equal to what? Not equal, but what? Is greater than 3.25. Okay? Using an old manufacturing, and that's the one-tailed test, and it's greater than, so it's on the what?
Right.
On the right. Using an old manufacturing process, the standard deviation, here we go. And again, if it's a population, it would be sigma, lowercase sigma. If it's a sample, it would be S. So it doesn't say here, so we'll just H of O is equal to 0.23. H of A, and I'm going to put H of A here because I put H of 1 there. So H of A, which should be less than, has what? Decreased. So 0.23. So that'd be a left tail test. So this is a right tail test. Or this is a, right tail. And this is a left tail test. And like I say, the reason I'm doing this is because I don't know how many of you have actually done this before. Okay? From what I'm seeing, I don't think you have. Okay. How many of you have seen this before? Okay, maybe 4 out of the whole class. Okay. So that means I need to go extra fast, right? Because my whole point is to get y'all to what? Fail. Okay, I think this is not equal. Okay. They should show a tail test, but they don't. Okay, two-tailed. There it is. And this one is greater than, and this one is less than. Capiche? Now y'all understand that, right? Okay, good. Because that's the first part that you need to understand. 4 outcomes of the, okay, here we go. Reject the null hypothesis. So write that down. Oh gosh, why don't they put all of them on one page? It's Russians. Just write reject the null hypothesis. Okay, reject the null hypothesis when the alternative hypothesis is true. Those are the ones, I'm going to do 2 types. I'm going to do the first type. I'm not going into the others, but I'm going to make it simple. I'm not going to try to trick you. All right, y'all got that one? Because they don't put them on one page. So, do not reject the null hypothesis when the null hypothesis is what? True. Do not reject the null hypothesis, which means fail to what? Fail to reject the null hypothesis, which means that you're going to accept the what? The null hypothesis. You see why I'm saying this when you need to get into it. Have you ever heard of not unusual?
Yeah.
What does not unusual mean?
Usual.
Normal or usual. But in some of these questions, they say not unusual. Do you remember me telling you that I believe statisticians were come about because they couldn't pass math? and that they made everything big to justify their profession? Well, that's one of the reasons. And in statistics and probability, you're not supposed to be held down to exact numbers or exact decisions. So that's why they use all these weird phrases, because you're not supposed to say except, or you're not supposed to say except, because that means that every single bag of M&Ms is going to have 10 green ones in it. Okay? So, and it's more of a liability, I guess, because somebody could come back and say, you told me there was going to be 10 and there's 11. Okay? So that's why. And if you're talking about being a quality assurance person for Michelin, and you're talking about millions and millions of dollars, you could actually lose your job. You see what I'm saying? So you can't use some of this terminology, and I understand that, but y'all are not going into Michelin next year with a six-figure job because you haven't got your degrees yet. Okay? This is an introductory. So by the time you get to quality assurance, you'll be going through so many daggum probability and statistics courses that you can just about call yourself a statistician. Okay? So it's not warranted here. Reject the null hypothesis. When the null hypothesis is true, this would be incorrect. Let's see if we just can't confuse the hell out of these students. Okay, you don't reject the null hypothesis when it's what? Okay, I'm not going to sit here and tell you to write that down. I think all of you know not to reject the null hypothesis if it's true. And how are you going to know if it's true? Because the alternative hypothesis will what? Will tell you. It will tell you. It will say, you're right. It will tell you either fail to reject, or you can say to yourself, not out loud in another math class, but you can say to yourself, accept the null hypothesis. Please don't say accept in another math class, please, because they're going to say, who taught you? And of course, y'all are going to say, Hubert. And then they're going to come to me and say, what did you tell you? And I'm going to have to tell them some obscenity and tell them to get out of my face. Do not reject the null hypothesis when the alternative hypothesis is true. Do not reject the null hypothesis when, okay, what is this saying? Don't believe the null hypothesis when you've proven the null hypothesis to be false. So these second 2, 3, and 4, do you really need to write those down? No. Okay, so in this section, it is the most difficult. Why is it the most difficult? Because you got to cut through a lot of stuff. And there's a prime example of 2 things that you don't need to know. 3 and 4 is not that big a deal. Okay, for each of the following, explain. Okay, I'm not going through this because this is going to confuse you. So we're going to move on. Okay, here we go. In other words, level of significance. Okay, write this down. We never accept the null hypothesis. This is what I've been saying to you for the last 20, 30 minutes. Without having access to the entire population. So that means we would have to open, before I give you 30 bags of M&Ms, I would have to open every single bag and make sure that there is 10 what? Green M&Ms in each bag, and throw the other green M&Ms away. All right? That's stretching it, but you see what I'm saying. Technically, you're lying when you say, I accept the null hypothesis that there's 10 in each bag. Okay? It doesn't matter if you're talking about green M&Ms, but if you're talking about millions and millions of dollars of defective tires, it's going to matter. We don't know the exact value of the parameter stated in the null. Rather, say, we do not reject the null hypothesis. This is just like the court system. We never declare the defendant innocent. Remember me telling you about innocent versus not guilty. Remember the pizza? Did I tell you the pizza scenario? I didn't?
I don't remember that.
Okay. Well, let's say Miss Williamson works at a pizza place. What's the pizza place? Papa John's Pizza. Papa John's. Okay? And Miss Williamson's got it going on, and Miss Williamson, she bought her a car, she's got her apartment, and she is assistant manager at Papa John's, and she's got everything going on. She works 50 hours a week, and she's making money, and everything's great. Okay? And she's got a roommate, and the roommate, I'm just going to say, is Bubba, okay? Because I can't use anybody negatively because they'll complain that I used them negatively and they're a snowflake and a buttercup and all that, and I don't feel like fooling with it. So I'm going to say Bubba. And Bubba sits at the apartment all day. He ain't got no job. He eats all the food. He drinks all the beer. And he borrows Miss Williamson's car all the time. Everybody with me? Now, of course, y'all won't run into this in your life. You'll never run into a Bubba. Okay? You will. Some of y'all will marry one. All right. Now, she goes to work on Friday night, but Bubba needs the car to go to Wendell's. Okay? So he says, can I borrow your car? Yeah, that's fine. I got to go to work at 5 and I get off at 10. Come pick me up at 10. Of course, he won't because he's drunk. But anyway, he takes her to work, and he goes to Wendell's and blah, blah, blah. And then he gets hooked up with some of his old friends. And she comes back. He doesn't come back. Yeah, he comes back, picks her up at, of course, 11 o'clock. And they go back to the room. And the next morning, police show up. And they handcuff Miss Williamson and take her to jail. Okay? Tell her that she has been accused of hooking a log chain up to an ATM and pulling it out the ATM door at the Quickie Mart or whatever. And she's going to jail for armed robbery or whatever. Will she ever see the inside of a courtroom?
Yes.
No, she will not. Why? One, she has a good, upstanding what? Reputation. Two, what is at the bank or where the ATM is? Cameras. What is at her work? Cameras. Okay? The bank was robbed at like 8 o'clock. Okay? She was at work at 5. Why will she not ever see the inside of a courtroom? She's innocent. Why is she innocent? Because she has 3 things of proof. She has a manager that says she's there at 5 till 10. She has cameras at the bank that shows, of course, her body build and Bubba's body build are not going to be the same, especially with a log chain. If anybody knows what a log chain is, that ain't one of those little chains like you put on your dog. Okay? A log chain is a real thick chain. All right? It's about 10 feet. It weighs about 25 to 30 pounds. All right? So you're not going to be able just to throw it over, Okay, so that's the second thing. And then the third thing, at 8 o'clock, she's running around Papa John's Pizza making pizzas. Okay? Because the film shows it. So she never will see the inside of the courtroom because she is innocent. She has an what? Alibi. Was O.J. innocent?
No.
What was he?
Not guilty.
Why?
He didn't have an alibi.
He didn't have an alibi. So he had to go to court. So the difference between not guilty and guilty is self-explanatory. If you got an alibi, how many of you have gotten in trouble before and you didn't have anything to do with it and you had to prove it before you got in trouble? This happened, okay? That's when you're innocent. When you're not innocent is when your friends go off and do something wrong and you can't prove where you were at that time. That's the difference between innocent and not guilty. Okay? Same thing with this. That's what they're trying to get to. Is it splitting hairs? Yes. But again, when you're talking about quality assurance and you're talking about having a career in statistics, it does matter. Okay, so that's that. Some of y'all are going, oh, that's neat. I didn't know the difference between not guilty and innocent. Well, there it is. All right. What time is it?
9:12.
I don't want to move too fast, so we're going to call it a day today.
Well, that's just that.
And I will extend, I'll fix your homework. Please don't spaz over the homework.
Yes, sir.
And please don't call me names.
Ain't nobody know you know that.
Oh, yeah, they did. SOB, bastard. Yeah, I guarantee you they called me names.